Hello, in this lecture we'll find out the radius of the circle. In the drawing we have a circle. Inside this circle we have chord DB equals to 2 units in its length, chord AC equals to the square root of 2 units in its length. This is angle DEB. The size of this angle DEB is 45 degrees. And our mission is to find out the radius of this circle. So the first step, we will join points A and D together by straight line. By joining points A and D, we create here peripheral angle BED. This is peripheral angle BED. We define the size of this peripheral angle BAD as x over 2. So this is peripheral angle BAD, and this peripheral angle BAD subtends on chord DB. Again, peripheral angle BAD subtends on chord DB. We define the center of this circle. This point is point O. We join points O and D together by a straight line. Likewise, we will join points O and B together by a straight line. By doing this construction, we get the central angle DOB. This is central angle DOB, and this central angle DOB is also subtends on the same chord called DB, exactly like this peripheral angle BAD that is also subtend on chord DB. So those two angles are both subtend on the same chord called TB. So now we can implement rule 13 in our drawing. I'll repeat quickly on rule 13. According to rule 13, the central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing you have a circle. Inside this circle we have peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB subtends on chord AB. Likewise, we also have here central angle AOB. This is central angle AOB, and this central angle AOB is also subtended on chord AB. So those two angles are both subtended on the same chord AB, and therefore according to this rule 13, the size of this peripheral angle AOB is twice as large as the size of this peripheral angle ACB. Why? Because of the fact that both those two angles subtend on the same chord called AB. The size of this peripheral angle AOB is theta, and therefore the size of this central angle AOB that subtend on the same chord called AB will be equal to 2 theta. So we can implement rule 13 in our drawing. Why? Because in our drawing those two angles they both subtend on the same chord called DB, and therefore the size of this central angle BOD must be twice as large as the size of this peripheral angle BAD. The size of this peripheral angle BAD is x over 2, and therefore the size of this central angle BOD that is subtend on the same chord called DB will be equal to x over 2 times 2, that is x. According to rule 13, of course. Likewise, we will define the side of this peripheral ADC. This peripheral ADC is y over 2. And this peripheral ADC is subtended on chord AC. The next step, we join points O and C together by step 9. And we join points O and A together by step 9. When doing this construction, we can do center triangle AOC. This is center triangle AOC. Center triangle AOC is subtended on chord AC, exactly like this peripheral ADC. It is also subtended on the same chord called AC. So those two angles, they both subtend on the same chord called AC. And therefore, according to rule 13, the size of this center triangle AOC will be twice as large as the size of this peripheral ADC, because of the fact that both of those triangles they subtend on the same chord called AC. The size of this peripheral ADC is y over 2, and therefore the size of this center triangle AOC will be equal to y over 2 times 2, that is y. In the next step, I'll copy the green triangle AED in a new page, and we will implement all 4 of this green triangle ADE. So actually, this is triangle AED that comes from the original drawing. Inside triangle AED we have those two angles x over 2 and y over 2, and this angle AED. All those three angles are defined as the interior angles of this triangle AED because of the fact that they are located inside triangle AED. So this angle and this angle, both those two angles are defined as the interior angles of this triangle AED. While this angle BED is located outside triangle AED, and therefore it is defined as the exterior angle of this triangle AED. So write it down. This is angle BED, and it is defined as the exterior angle of this triangle AED. Okay, so in the next step, I will present to you rule 4, and we will implement rule 4 in this triangle AED. according to rule 4, the exterior angle of a triangle is equals to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles, A, B and C. All those three angles are defined as the interior angles because of this triangle, because they are located inside the triangle, while this is angle E, which is located outside the triangle, and therefore it is defined as the exterior angle of this triangle. According to this rule 4, the size of the exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. So inside this triangle we have three angles, A, B and C. All those three angles are defined as the interior angles of this triangle. This is angle C, that is the interior angle of this triangle, but angle C is adjacent to angle E, and the two other angles that are not adjacent to angle E are A and B. And according to this rule 4, the side of the exterior angle E is equals to the sum of the two interior angles that are not adjacent to it. That is to say, it equals to A plus B. So angle E equals to angle A plus B according to this rule 4. Why? Because A plus B is the sum of the two interior angles that are not adjacent to angle E. So according to this rule 4, angle E equals to A plus B. So I can actually implement rule 4 in this triangle AED. We have the exterior angle BED. And according to rule 4, the size of the exterior angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle BEA. Angle BEA is definitely adjacent to angle BED. And the two other angles that are not adjacent to angle BED, this angle BED, are y over 2 and x over 2. And the sum of those two angles is y over 2 plus x over 2. So in conclusion, we found out that according to rule 4, the size of the exterior angle BED will be equal to y over 2 plus x over 2. So write it down. The size of the exterior angle BED is equal to the sum of the two interior angles that are not adjacent to this angle BED. The two interior angles that are not adjacent to angle BED are x over 2 and y over 2. And the sum of those two angles is of course x over 2 plus y over 2. So the size of the exterior angle BED will be equal to x over 2 plus y over 2 according to rule 4. But it is given as the question that the size of angle BED, this angle is 45 degrees. So we substitute angle BED by 45 degrees, and we get that 45 degrees is equal to x over 2 plus y over 2. So here we multiply this equation by 2, and finally we get that 45 degrees times 2 is 90 degrees. So 90 degrees equals to x over 2 times 2 is x, and y over 2 times 2 is y. So in conclusion, we found out that x plus y equals to 90 degrees. X plus y equals to 90 degrees. We subtract x from this equation, and finally we get that y equals to 90 degrees minus x. So number 3, so we go into equation 1, y equals to 90 degrees minus x. In the next step, I'll repeat quickly on the law of cosines, and we will implement the law of cosines on this triangle BOD and this triangle AOC. So, the law of cosines is true in any triangle. So actually, this is triangle ABC that could be any triangle. This triangle ABC, the length of side AB is A, side AC equals to B units in itself, and side BC equals to C units in itself. This is angle BAC, the size of angle BAC is theta. According to the law of cosines, the following equation will put true in this triangle ABC that could be any triangle. Cosine theta equals to A square plus B square minus C square over 2 times A times B. Again, cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay, so in the next step, I'll copy this triangle BOD in the new page, and we will implement the law of cosines in this triangle BOD. But before that, line segment BO equals to line segment OD equals to line segment OC equals to line segment OA. They're all the radii of this circle, and therefore they are equal to each other. If we define the radius of this circle as R, then each line segment will be equal to R. All of those two line segments are the radii of the circle, and therefore they are equal to each other. So each of them is equal to R. So the length of line segment OB is R, it is the radius of the circle. OD also equals to R, OC equals to R, and OA also equals to R. So in the next step, I'll copy the right triangle BOD in the new page, and we'll implement the law of cosines in this triangle BOD. Side DB equals to 2 units in its length, according to what is given as the question. So finally, this is triangle OBD that the correct from the original drawing. Now we'll implement the law of cosines in this triangle BOD. Side DO equals to side BO, they are both the radii of the circle, that equals to R, according to our definition. So in this triangle BOD, cosine x will be equal to OD square plus OB square minus DB square over 2 times OD times OB. So I write it now. According to the law of cosines, in this triangle DOB, cosine x equals to DO square, DO is R, therefore DO square is R square, plus OB square. OB is also R, therefore OB square is R square, minus DB square. DB is 2, therefore DB square is 2 squared, that is 4. So it is minus 4 divided by 2 times the OD, that is R, times OB, that is also R. So it is 2 times R times R. R square plus R square is 2R square. So in total, in the numerator of this expression, we have 2r squared minus 4 divided by 2 times r, that is 2r squared. So here we have 2r squared over 2r squared is 1, and we have also here minus 4 over 2r squared. So cosine x equals to 1, and we have here minus 4 over 2r squared. We divide both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2r squared over 2 is r squared. So in conclusion, we found out that cosine x according to equation 1 equals to 1 minus 2 over r squared. And again, according to equation 1, cosine x equals to 1 minus 2 over r squared. In the next step, I'll copy triangle AOC in the new print, and we'll implement the law of cosines in this triangle AOC. Side AC equals to the square root of 2 units in itself, according to what is given us the question. So actually, this is triangle AOC, that the curvature of the range of going. According to the law of cosines, in this triangle AOC, cosine y will be equal to AO squared plus CO squared minus AC squared over 2 times AO times CO. So I write it down. This will be equation 2. Cosine y equals to AO squared. AO is out, therefore AO squared is R squared plus OC squared. OC is also out, therefore OC squared is R squared, so it is plus R squared minus AC squared. AC is square root of 2, therefore AC squared is square root of 2 squared, that is 2, so it is minus 2 divided by 2 times OA. OA is R times OC. OC is also R. So in conclusion, if we found out that according to the law of cosines, so I it is according to the law of cosines, here also the first triangle OBD is according to the law of cosines. And again, according to the law of cosines, in this triangle OSC, cosine y equals to r squared plus r squared minus 2 over 2 times r times r. R squared plus r squared is 2r squared, so in total in the numerator of this expression we have 2r squared minus 2 divided by 2r squared. So here we have 2r squared over 2r squared is 1, and also here minus 2 over 2r squared. So if we found out that cosine y equals to 1, and here we have minus 2 over 2 all square. Here we divide both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, and 2 all square over 2 is r square. So, in conclusion, I actually found out that according to equation 2, cosine y equals to 1 minus 1 over r square. This is according to equation 2. But we have only found out that y equals to 90 degrees minus 6. So can I do that? Y equals to 90 degrees minus 6. So now we can substitute y in this equation 2 by 90 degrees minus 6. We do it now and we get that according to equation 2. Cosine y, and y is 90 degrees minus 6, equals to 1 minus 1 over r square. So repeat again, we actually found out that according to equation 2, cosine y equals to cosine 90 degrees minus x equals to 1 minus 1 over r square. So we have the trigonometric identity that says that sinus x equals to cosine 90 degrees minus x. So according to this trigonometric identity, we can substitute cosine 90 degrees minus x in this equation 2 by sinus x. We do it now, and we get that according to equation 2 we have cosine 90 degrees minus 6, that is sinus x, and it is equals to 1 minus 1 over r square. This is according to equation 2. When according to equation 1, we have only found out that cosine x equals to 1 minus 2 over r square. So actually have here the values of sinus x and cosine x in terms of r. Here we use the following trigonometric identity. That says that sinus square x plus cosine square x equals to 1. Okay. We have, according to equation 2, sinus x equals to 1 minus 1 over r square. If sinus x equals to 1 minus 1 over r square, it means that sinus square x will be equal to 1 minus 1 over r square square. We have here plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r square. If cosine x equals to 1 minus 2 over r square, it means that cosine square x will be equal to 1 minus 2 over r squared. So this expression is sin square x, this expression is cosine square x, and sin square x plus cosine square x equals to 1 according to this trigonometric identity. So it will be equal to 1. So I shall find out that 1 minus 1 over r squared plus 1 minus 2 over r squared equals to 1. In the next step, we will define t as 1 over r squared. Again, t equals to 1 over r squared according to our definition. Now we can substitute 1 over r squared in this equation 3 by t. Again, we substitute 1 over r squared in this equation 3 by t. We do it now, we get that we have here 1 minus 1 over r squared. 1 over r squared is t. So we substitute 1 over r squared by t, so it will be 1 minus t squared. We have also plus 1 minus 2 over r squared. Here we multiply this expression by 1. It is allowable to multiply any expression by 1 because by multiplying the expression by 1 will not change the value of the expression. So this expression equals to 1 minus 2 times 1 over r squared. 1 over r squared is t, therefore we substitute 1 over r squared by t. So in total, this expression will be equal to 1 minus 2t squared. And it is equal to 1. So in conclusion, we found out that according to equation 3, 1 minus t squared plus 1 minus 2t squared equals to 1. So here we'll open the brackets on this side of this equation 3. And again that according to this equation 3, we have 1 minus t squared. 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t, plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, so it is plus 4t squared, minus 2 times 1 times 2t. 2 times 1 plus 2 times 1 times 2t is minus 4t. And it is equals to 1. Here we have 1 on both sides of this equation 3, so 1 we get cancelled. After cancelled 1, this side of the equation 3 we left with t squared plus 4t squared is 5t squared. And we have here minus 2t minus 4t is minus 6t. Plus 1 equals to 0. So if I found out that according to equation 3, according to equation 3, 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is general formula. A, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Another specific quadratic equation that is to say 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t, so x equals to t. The coefficient a equals to 5. The coefficient b equals to minus 6. And finally, the coefficient c equals to 1. The only thing that we have to do is to put the data of our specific quadratic equation, that is to say this data inside this general formula for x, and in this way we find out the value of the values of t because x equals to t. So we do it now, and we get that again x equals to t, so we substitute x in this general formula by t. So t equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus the root of b squared. B is minus 6, therefore b squared minus 6 squared, that is 36, minus 4 times a. A is 5, so minus 4 times 5 is minus 20, times c. C is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, so 2a is 2 times 5, that is 10. So in conclusion, we found out that t equals to 6 plus minus root of 36 minus 20 over 10. So t equals to 6 plus minus, inside the root we have 36 minus 20. 36 minus 20 is 16 divided by 10. So we found out that t equals to 6 plus minus, and the square root of 16 is 4 divided by 10. So here we will have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1 from one side, but from the other side, according to our definition, t also equals to 1 over r squared. Therefore, we can substitute t in this equation by 1 over r squared. We'll do it now, and we get that 1 over r squared equals to 1. Here we multiply this equation by r squared. And finally we get that r squared equals to 1. So here we take out of this equation. And finally we get that r, that is the radius that we're looking for, the radius of this circle r is equals to the square root of 1. The square root of 1 is 1, so r equals to 1 unit in itself. So I should found out that the radius of this circle r is equals to 1 unit. But it is actually impossible that the radius of this circle is equals to 1. Why? Because of the fact that we know that this is called dB is equals to 2 units in itself. According to what is given as the question, the length of code dB is 2 units. But it is very easy to see from the drawing that chord dB is definitely not the diameter of the circle. Again, chord dB is definitely not the diameter of the circle. So as you know, from the drawing, it is very easy to see that chord dB is not the diameter of the circle. But we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. What is the diameter of this circle? The diameter is of course 2r. Again, the diameter of this circle is 2r. So, the diameter 2r is the longest chord in the circle, and therefore it is definitely greater than db that is not the diameter. Again, the diameter 2r that is the longest chord in the circle is definitely greater than db that is not the diameter. And db is 2, and for this equation 2r is greater than db is equals to 2. We will derive that 2r is greater than 2. So if we found out that 2r is greater than 2, here we will divide this inequality by 2. Finally we get that the radius r of the circle is greater than 1. So if the radius r is greater than 1, the radius cannot be equal to 1. Okay, if the radius r is greater than 1, the radius cannot be equal to 1. So therefore, the first solution for t is a correct solution. We cancel this solution, and we're left only with the second solution for t. The second solution for t, here we have t equals to 6 minus 4 over 10. This will be the second solution for t. T equals to 6 minus 4 over 10. So write it down. According to the second solution for t, t equals to 6 minus 4 over 10. Repeat again. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So the second solution for t is that t equals to 1/5 from one side, but from the other side, according to our definition, t is also equals to 1 over r square, and therefore we can substitute t in this equation by 1 over r square. We do it now, we get that 1 over r square equals to 1/5. Here we cross multiply this equation, and finally we get that r square equals to 5. So here we take the root out of this equation, and finally we get that the radius r that we are looking for, the radius r of the circle is equals to either the square root of 5 units in its length. In terms of numbers, it is equals to 2.236 units. Repeat again, as we found out that the radius r of this circle, it is equals to either square root of 5 units in its length, or in terms of numbers, it is equals to 2.236 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have a circle. Inside the circle, we have chord dB, is equals to 2 units in its length. Also, we have here chord AC. The length of chord AC is chord of 2. And actually, we have also two other chords, AB and DC. We don't know the length of those two chords. And we also have here, this is angle DEB, the size of angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So in the first step, we join points A and D together by straight line. By joining points A and D, we can get this triangle DAB. This is triangle DAB. We define the size of this triangle DAB as x over 2. So this triangle DAB is subset on chord DB. Again, triangle DAB, this angle triangle DAB is subset on chord DB. In the next step, we define the center of this circle, this point is point O. Then we join points O and B together by straight line. And then we also join points O and D together by straight line. By doing this construction, we're going to do center angle DOB. This is center angle DOB. And this center angle DOB is also subtended on the same chord called DB. So those two angles are both subtend on the same chord called DB. So now we can implement here all 13. So I'll repeat quickly on all 13. According to all 13, the central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing of a circle, inside this circle we have, this is peripheral angle ACB. The size of this peripheral angle ACB is theta. And this peripheral angle ACB is subtended on chord AB. Likewise, we have also here central angle AOB. This central angle AOB is subtended on the same chord called AB. So those two angles, they both subtend on the same chord called AB. And therefore, according to this rule, all 4, the size of this central angle AOB will be twice as large as the size of this peripheral angle ACB, because both of them subtend on the same chord called AB. The size of this peripheral angle ACB is theta, therefore the size of the central angle AOB will be equal to 2 theta. So correctly implement rule 13 in our drawing. Why? Because in our drawing we have those two angles that both subtend on the same chord called DB. The size of this peripheral angle DAB is x over 2, and therefore the size of the central angle DOB that is subtended on the same chord called DB must be equal to x over 2 times 2, that is x. According to rule 13, of course. In the next step, we define the size of this peripheral angle ADC. This is angle peripheral angle ADC. We define the size of this peripheral angle ADC is y over 2. Peripheral angle ADC. This is peripheral angle ADC, and this peripheral angle ADC is subset on chord AC. In the next step, we join points O and C together by straight line, and we also join points O and A together by straight line. By doing this construction, we get the center angle AOC. This is center angle AOC, and this center angle AOC is subtend on the same chord called AC, exactly like this peripheral angle AC, ADC, that is also subtend on the same chord called AC. So those two angles are both subtend on the same chord called AC. And therefore, according to rule 13, the size of this central angle AOC will be twice as large as the size of this peripheral angle ADC. The size of this peripheral angle ADC is y over 2, and therefore the size of the central angle AOC that is subtended on the same chord called AC will be equal to y over 2 times 2, that is y. Okay. In the next step, I copied the green triangle ADE in the new page, and we implemented all 4 in this green triangle ADE. This is the green triangle ADE that I got from the original drawing. This is angle EDA. The size of angle EDA is y over 2. The size of this angle EAB is x over 2. and we also have here this angle DEA. Actually, those three angles are all defined as the interangles of this triangle DEA. Why? Because of the fact that all of those triangles are located inside this triangle EDA. Well, this is angle BED that is located outside triangle EDA, and therefore it is defined as the external of this triangle EDA. So, okay, the next step I presented to you rule 4, and we implemented rule 4 in this triangle EDA. According to rule 4, the external angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So, in the drawing, we have a triangle. Inside this triangle, we have three angles, A, B, and C. All those three angles, A, B, and C, are defined as the interior angles of this triangle, while this is angle E that is located outside this triangle. Therefore, angle E is defined as the external angle of this triangle. According to this rule 4, the size of the external angle E is equal to the sum of the two interior angles that are not adjacent to it. Angle C is adjacent to angle E, and the two other angles that are not adjacent to angle E are A and B. And the sum of those two angles is of course A plus B. So according to this rule 4, the size of angle E is A plus B. Again, angle E equals to A plus B according to this rule 4. And so the size of the external angle E is equal to the sum of the two interior angles that are not adjacent to it. And the two interior angles that are not adjacent to it are A and B. So the size of angle E is equal to A plus B. E equals to A plus B according to this rule 4. We can actually implement rule 4 in our drawing. Why? Because in our drawing we have, this is the external angle BED. The size of external angle BED is 45 degrees. According to rule 4, the size of angle BED, the external angle BED, is equal to the sum of the two interior angles that are not adjacent to it. This angle AED is definitely adjacent to angle BED. The two other angles that are not adjacent to this angle BED are x over 2 and y over 2. And the sum of those two interior angles that are not adjacent to it is of course x plus 2 plus y over 2. And therefore, according to rule 4, the size of the external angle BED will be equal to x over 2 plus y over 2. Repeat again, the size of the external angle BED according to rule 4 will be equal to x plus 2 plus y will be equal to x over 2 plus y over 2. And there are the two interior angles that are not adjacent to angle BED. Again, according to rule 4, the size of the external angle BED will be equal to x plus 2 plus y, x over 2 plus y over 2. Okay, but angle BED equals to 45 degrees according to what is given as the question. So you can substitute angle BED by 45 degrees. And if we found out that 45 degrees equals to x over 2 plus y over 2, we will multiply this equation by 2, and finally found out that 45 degrees times 2 is 90 degrees, and it is equal to x over 2 times 2, that is x, plus y over 2 times 2, that is y. So in total we shall found out that 90 degrees equals to x plus y. We subtracted x from this equation, and finally found out that according to equation 1, y equals to 90 degrees minus x. Okay. In the next step, I will present to you the law of cosines, and we implemented the law of cosines on those two triangles, triangle DOB, and this triangle AOC. We implemented the law of cosines on those two triangles. So, what is the law of cosines? The law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. The length of side AB is A, side AC equals to B units in length, and side BC equals to C units in length. According to this law, the law of cosines, and angle BAC, the size of angle BAC is theta. According to this law, the law of cosines, the following equation will be true: that cosine theta equals to a squared plus b squared minus c squared over 2 times a times b. Again, cosine theta equals to a squared plus b squared minus c squared over 2 times a times b. So can I implement the law of cosines in any triangle, and especially we can implement the law of cosines in triangle BOD. So I copy triangle BOD in a new page and implemented the law of cosines in this triangle BOD. But before that, it's very easy to see that AO equals to CO equals to BO equals to DO. They are the area of this circle. We define the radius of this circle as R, and therefore each of those 4 line segments is equal to R. Each of them is the radius of the circle that is equal to R according to our definition. So in the next step I call it triangle BOD in the new page, and we implemented the law of cosines in this triangle BOD. So actually this is triangle BOD or OBD that I call it from the original drawing. OD equals to OB equals to R, and DB equals to 2 units in this time according to what is given as the question. This is again BOD is equal to X according to the law of cosines. This triangle BOD, cosine X equals to OD square. OD is R, therefore OD square is R square, plus OB square. OB is also R, therefore OB square is R square, so it is plus R square, minus DB square. DB is 2, therefore DB square is 2 squared, that is 4, so it is minus 4. So in total, in the denominator we have Rx plus R square plus R square minus 4, divided by 2 times OD, that is R, so it is 2 times R, times OB, that is also R, so it is 2 times R times R. So actually found out that according to equation 1, cosine X equals to R square plus R square, that is 2R square, minus 4 over 2 times R is 2R square. So cosine X equals to 2R square minus 4 over 2R square. 2R square over 2R square is 1, and we have also minus 4 here, minus 4 over 2R square. So cosine X equals to 1, and here we divided both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2R square over 2 is R square. So in conclusion, we found out that according to equation 1, cosine X equals to 1 minus 2 over R square. In the next step, I copied triangle AOC in a new page and implemented the law of cosines in this triangle AOC. So actually, this is triangle AOC that I copied from the original drawing. Side AC equals to the square root of 2 units. AO equals to CO equals to R. Each of them is on the other circle, and therefore each of them is equal to R. This is again AOC. The size of this again AOC is Y. So according to the law of cosines, in this triangle AOC, cosine Y equals to AO square. AO is R, therefore AO square is R square, plus CO square. CO is also R, therefore CO square is R square, minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2, so it is minus 2. So in total, the numerator of this expression we have R square plus R square minus 2, divided by 2 times AO, that is R, times CO, that is also R. So in total, it is 2 times R times R. So according to equation 2, actually found out that cosine Y equals to R square plus R square, that is 2R square, minus 2 over 2 times R, that is 2R square. So we have cosine Y equals to 2R square over 2R square is 1, and also here minus 2 over 2R square. We divided both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, and 2R square over 2 is R square. So in conclusion, we found out that according to equation 2, cosine Y equals to 1 minus 1 over R square. This is according to equation 2, but we already found out that Y equals to 90 degrees minus 6. Therefore, we can substitute Y in this equation 2 by 90 degrees minus 6. We did it. Actually found out that cosine Y is cosine 90 degrees minus 6, and it is equal to 1 minus 1 over R square. But again, actually found out that cosine 90 degrees minus x equals to 1 minus 1 over r squared. But we also have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. According to this trigonometric identity, we can solve the cosine 90 degrees minus x in this equation 2 by sinus x. We did it. And here, so I found out actually that cosine 90 degrees minus x is of course sinus x. According to this trigonometric identity, and it is equals to 1 minus 1 over r squared. This is according to equation 2, and according to equation 1, we already found out that cosine x equals to 1 minus 2 over r squared. So we have the values of sinus x and cosine x in terms of r. That is the radius of the circle, that is the radius that we are looking for in this question. Then we use the trigonometric identity that states that sinus square x plus cosine square x equals to 1. According to equation 2, sinus x equals to 1 minus 1 over r squared. If sinus x equals to 1 minus 1 over r squared, it means that sinus square x will be equal to 1 minus 1 over r squared. And we have also here plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r squared. If cosine x equals to 1 minus 2 over r squared, it means that cosine square x will be equal to 1 minus 2 over r squared, and it is equals to 1. So if you found out that sinus square x is actually 1 minus 1 over r squared, and cosine square x is actually equals to 1 minus 2 over r squared, and it is equals to 1 according to this trigonometric identity. In the next step, we substitute 1 over r squared by t, because according to our definition, t equals to 1 over r squared. After we substitute 1 over r squared by t, we found out actually that this expression equals to 1 minus 1 over r squared, that is t. So in total, this expression will be equal to 1 minus t squared, and we have also here plus 1 minus 2 times 1 over r squared. So it is 1 minus 2 times 1 over r squared is t, so it is 1 minus 2t squared, 1 minus 2t squared, and it is equals to 1. So in conclusion, we found out that according to equation 3, 1 minus t squared plus 1 minus 2t squared equals to 1. We open the brackets of this side of this equation 3, and we found out actually that according to equation 3, 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t, and we have also plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, plus 2t squared. 2t squared is 4t squared, minus 2 times 1 times 2t is minus 4t, and it is equal to 1. Here we have 1 on both sides of this equation 3, so 1 we cancel. After we cancel 1, in this side of the equation we have t squared plus 4t squared, that is 5t squared, and we have also minus 2t minus 4t, that is minus 6t, plus 1 equals to 0. Repeat again, we should find out that five t squared minus 6t plus 1 equals to 0. So actually, this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, to this general quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Now a specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. The only thing that we have to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we find out the value of the values of t, because x equals to t. So x equals to t, therefore we substitute x by t, and it is equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus root of b squared. B is minus 6, the whole b squared is minus 6 squared, that is 36, minus 4 times a. A is 5, so minus 4 times 5 is minus 20, times c. C is 1, so minus 20 times 1 is minus 20. So in total, if we inside the root, we have left only 36 minus 20, divided by 2a. A is 5, so 2a is 2 times 5, that is 10. So if we found out that t equals to 6 plus minus, inside the root we have 36 minus 20, that is 16, divided by 10. So t equals to 6 plus minus, the root of 16 is 4, divided by 10. So if we found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10 and 10 over 10 is 1. So according to the first solution for t equals to 1. From one side, but from the other side, according to our definition, t also equals to 1 over r squared. So now we can substitute this equation by 1 over r squared. We did it, and we actually found out that 1 over r squared equals to 1. Here we multiplied this equation by r squared, and finally found out that r squared equals to 1. We took a root out of this equation, and finally found out that the radius r is equals to the square root of 1, that is 1. So actually found out that the radius of this circle r equals to 1. But it is actually impossible that the radius of this circle r equals to 1. Be equal to 1. Why? Because of the fact that we have f chord db equals to 2 units according to what is given in the equation. You know the chord db. This is called db, that is equals to 2 units in its length, and it is very easy to see that chord db is not the diameter of the circle. Again, chord db is definitely not the diameter of the circle. So chord db equals to 2, and chord db is not the diameter of the circle. But we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. What is the diameter of the circle? The diameter of this circle is of course 2r. So the diameter 2r of our circle is the longest chord in the circle, and therefore it is definitely must be greater than db. It is not the diameter. So the diameter 2r must be greater than db. It is not the diameter, and db is 2. So from this equation we derive that 2r is greater than 2. 2r is greater than 2. Here we divided this inequality by 2 and finally found out that the radius r is greater than 1. If the radius r is greater than 1, the radius r cannot be equal to 1. So this solution is an incorrect solution. So we actually cancel the first solution for t, and we left only for the second, we take into account only the second solution for t. The second solution for t is that t equals to 6 minus 4 over 10. And again, the second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So if you found out that according to the second solution for t equals to 1/5 from one side, but from the other side, according to our definition, t also equals to 1 over r squared. So we can substitute this equation by 1 over r squared. We did it, and we actually found out that 1 over r squared equals to 1/5. Because multiply this equation, and I found out that r squared equals to 5. We took a root out of this equation, and finally found out that the radius r of this circle, that is the radius that we are looking for in this question, it is equals to either the square root of 5 units. In terms of numbers, the radius r of this circle is equals to 2.236 units. Okay, thank you very much.